Welcome everyone. It's Monday, fun day, which means it's time for another coding challenge. And this stream is for entertainment purposes only. Let's see what we've got today. Hopefully not another dynamic programming question like last time. Okay, pick one. Again, hard problem. Why on earth it's always hard problem? Shortest palindrome. You're given a string s. You can convert s to palindrome by adding characters in front of it. Return the shortest palindrome you can find by performing this transformation. So to make it in a way that we can you can convert s to palindrome by adding characters in front of it. So the length is from 0 to 5 to 10. Consists of lowercase English letters only. So for the string to be palindrome, we basically need the shortest palindrome we can find by performing this transformation. So the keyword is shortest, right? Yeah. I hope it's not dynamic programming. Really hope so. All right. So what can be the key here? What are the correct answers? What are the correct questions we may ask here to maybe give us a hint what to do? So, and it means in front, like we part it from the first letter, right? Such that if we flip it, it should match the initial one, right? Well, basically, alternatively, we may just initially flip another one, right? And then start adding something to both for one in the front, for another one at the end, and then do check. The thing is, the check won't be really fast because, okay, let's see the whiteboard. All right, so we start with example 2, A, B, C, D, because it seems more interesting to me. So we have A, B, C, D. So if we revert this string, immediately we have D, C, B, A. All right. So by adding elements here and in front of this, and by adding elements at the end of these, so we end this like all the time the same element, this string should become equal. So obviously right now, if we flip them, then the shortest possible answer will be the intersection of this, right, at the beginning with this at the end. Once we find this intersection, find intersection in the, sorry. Or you know what? We're all math people here, right? So let me just use math. So I will use special color for math always. You all know what this means, right? So how do we do this? Well, obviously we just start from I0 here, and this length, we need return, oops, sorry, length minus I. to say, right? And we start comparing them. Once we find A, B, C, C, B, A, oh, it's actually, yeah, so in this case, no, 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 it's not like that. It's not like that, and the reason is we shouldn't do intersection. Or correct way is yes, is to intersect them, but we will slide it in the following way, right? We will slide it this side until this letter matches with something, right? Once it matches, we then check second letter. If it doesn't match, we move it one way in the other one. So in the worst case, it will match against A. In the best case, like, so this was what, example 2, right? 2, oops, no. For example 1, we have what? A, C, E, C, and triple A, right? So a good example, because if you flip it, it's basically exactly the same, right? You see? The only difference, we now have only 2A at the back. So once we start sliding it, basically we will find that this thing matches with this thing. So we need to add only one A here, right? So this is our answer. In this case, only this thing will match with this thing. So we need to add basically this in front of this, right? Correct. I see. So this is algorithm, right? So the algorithm is straightforward. Algorithm. A, find intersection. Find intersection section using sliding window hopefully in linear time, right? 2, once we found intersection, 2, concatenate add diff with reversed string, right? String to S. That's it. So the algorithm is straightforward. We flap the sequence, and maybe we can just steal some code from Stack Overflow for that. So we don't need. Maybe there is some API to reverse string, I don't know, that does it in linear time, so we don't need to program it separately. Once we have it, then it will be more interesting. How would we slide it until it matches, right? It looks like it's quadratic complexity here. So like we start like this. We just compare this one. It doesn't work, then we remove one here, compare again. Doesn't work. We remove one here, compare again. Doesn't work. And boom, works. So then we say, okay, this needs to add this in front, right? So every time when we compare two strings, it's technically ON. And we remove one element and then compare it again. It's again ON minus one. So it's technically I would imagine something like n square half, but whatever, it's quadratic, because in the worst case, we will go to the last digit. But again, we can start with this version and see if, if it's sufficient. All right, let's switch to the default scene. So we have string, let's call it pad, and string, let's call it reverse. All right, let me quickly check in Stack Overflow, reverse string CPP. If there are any existing methods already, so we don't need to program them. Is it swap only method? Yes, okay. Let's just do this. It will take linear complexity, right? I don't see any. Ah, exactly. Here we go. Yeah, this is much simpler. We can start from the beginning to the end, or we can start, I believe it's called reverse beginning, reverse end, if I remember this correctly. So that's how we do it. Not sure if it works, but so this should reverse in linear time. Whatever, we are not worrying much right now about the complexity. Mm-hmm. So we start for I equals 0. You know this meme that while and do while. Yeah, this looks elegant. However, I prefer 4 cycles. S length and I plus plus. So obviously we need to add space here, so it looks more, professionally. So now, what we need to do is check if S, so substring, I believe the syntax is, so from the beginning till S length minus I, right? And should it be, well, definitely the last element will be the same, right? At least the last element will be the same. So we already don't need to go fully here. So it's -1 equals can I call reverse just R? Just one, just for simplicity. So R, basically the same thing, but we need substring from I to the end, right? So if I is 0, it's the entire string. If I is 1, then it's from without first element and so forth. So this, if it's equals, break, else pad plus equal, what? Pad plus equal, it's basically one character, right? Or you know what? We don't need this actually. We don't need pod, we don't need this. We can just return from here immediately. Just return. So once it's equal, right? So in this case, I will be what? Will be 3, right? Like in the example 2. In this case, I will be 1. So we say this is from 0 to I. Yeah, exactly. Where is my... So here we go. Return from 0, oops, 0 to I. So everything before I in the reverse string plus S. That's it. And this one, we should never reach this statement, by the way, but we can say nothing. So should never reach. Never reach. Or whatever. Should never return. Just should, or whatever. So here is or. So the only problem so far I see is this function. So maybe if you have enough time, we can see how we can simplify this. Because this checks is ON, right? And I don't really like it. Because technically, every time we slide it by one letter only, right? So it's like stupid to redo the check of the intermediate things in the middle. We only need to remove one at the beginning and add one at the end here, and vice versa for the reverse. No, vice versa. So for the initial string, we remove from the end, right, every time by one letter. So every time we actually shrink our window that we check. And for this one, we also do this. Yeah, I don't. Yeah, it seems like it's a worst case complexity, right? So everything is equal but one, but then once you shift by one, then everything is equal and that's it, you're done. Yeah, so maybe we never achieve this asymptotic complexity, and amortized complexity will be fast enough to pass the test. Again, for hard problems, sometimes you just need to pass the test. And again, many people like this, so maybe it works. Let's see if reverse at least works. Let me use sophisticated debugging tools here. Reverse. R, right? Basically, we don't need anything than that. Just to check that reverse works. Okay, run code. See what we've got. Oh, so reverse works most likely. Seems like. So it's accepted. So it's correct. So let's see if we can. Is it like this? Should be. I'm not sure how to format it correctly. Let's see. ABCD output empty because we never reach this thing. Why? So let's, I stopped too early. Okay, let's see. Seems weird to me that it doesn't pass this one. DCBA. So let's actually print here another debugging technique. S sub str right, and then the same for reverse substring, and it's what, and it's this. Most likely some index problem. Still don't see why, but could be the fact how the substring works. So let's see. Okay. I don't see why it is the case. Yeah, we start like this, and we can see that initially we just check if it's already a palindrome, right? If it's not, then we subtract by 1, it matches, and we say, hey, just add a at the beginning. So, but in this case, we have return empty one, which means this condition here was never triggered, and it's weird. Because if I reverse, then once I becomes 3, right, I should return, so it will be just I here and the last element here, and it should be equal. Let's see why it's not. And then we say return basically DCB plus ABCD, and then it becomes this one. But let's see. Maybe we missed something here, or maybe it's just. Okay, so the most interesting part, yes, DBCDA. So basically, we don't need this now. Then we ABC, right? Then we just check ABC and CBA. And CBA doesn't work. AB and BA doesn't work. And why we stopped? Ah. Oh, yes. Yes, because in this case, I'm saying S length minus 1, because the last one I said is always equal, right? So it doesn't make sense to check for it. Yeah. So in this case, it's actually straightforward now. In this case, all we need to do is just return this thing. It's basically the entire reverse string except the last element plus the string. If only first char matches with reverse last char. Now this thing should work. Yeah, time limit exceeded. That's what I'm saying. It works, but this is too slow. But we have about 20 minutes to fix that. Oh, it's just one last test. Just one last test. Oh my gosh. All right. We definitely can beat the linear complexity here. There is no way. There is no way. And another interesting thing, actually, we can reverse for to while, so we don't need this thing. We can say while this, so we just say int I equals what? S length minus 1. This thing, right? What do we do here? We just check while this equals, we keep subtracting I minus minus, right? So we're kind of reducing it by 1. It's still the asymptotic complexity is the same, but we start sort of with the worst case when just one matches, and then we kind of shrink it. So once it's no longer matches, right? So what can we say? Or we can say minus minus I, it doesn't really matter. What can we say? But oh, actually, we can just say uh, plus minus 1. Yeah, it's fine. Whatever. So once it's done, so we know that the new I, for the new I, they're no longer matching, right? So what we say here is that we need the substring I, right? Probably plus 1 and plus S. So this is also linear. This concatenation is linear with respect to S. So what's missing here is this part. It's still kind of can be quadratic in a sense because I still do this equal sign here, and I wonder if we can simplify things. Yeah, but we don't know what to compare against, right? Okay, well, let's check that it works in the first example. And if so, no. Oh, gosh. Something is wrong here. Yeah, no, it won't guarantee exactly because like in this case, yes, A is matching, but second one not necessarily will match to the reverse, right? Like in A, B, C, D case, you start with A is matching, but then it's no longer matching, right? But then in this case, if we start just checking A, then we add another A and check this, matches, C matches, C matches. Yes, it's no longer matches and it breaks here. But if we take this one, then it matches. Yes, so the initial algorithm was right. So then we need to think then we really need to think how to do this check. In a way that It's not that bad overall. At least we cracked the problem, we just didn't found the optimal solution for it. So let's return to the whiteboard. We still have about 10-ish, 12 minutes to rethink. So in this case, okay, example 2, we're done with it. It's not interesting, kind of boring. The algorithm itself is kind of boring. Now we need the way how to reduce, how to do the sliding window thing, right? So we need a custom method to compare to strings and with some indices, right? So imagine, so we start with this, right? So the first time I need to compare all elements, right? So I'm just comparing them. And let's say this, let's see, the bluish one. So this thing is not equal, obviously. Then what we say? Then we say, okay, let's remove element from here, right? So we say, let's just now use this part and compare it against this part. Do we really need to check all of the elements? Because what we do basically, we kind of slide one against another, right? So we can't just say, okay, don't touch this and don't touch, like, say, start from the middle and then subtract by 1 from this side or that side. We still need to check element by element. Yeah, I don't see. So the problem is in the sliding window. If we know that in the middle we checked elements already, or maybe can we do just one check, right? Can we just, once we checked once, like this, right? We see what? Let's see some random. Let's give some number, random thing. PS W X Y V Y, something like this, right? So we reverse it, so it's Y X W S B Y W, right? Can we just check? So we check this element, doesn't work. Then we obviously we don't need to check all other elements. We already know it doesn't work. Then we shift it to X, doesn't work. Then we shift it here. Now it works. So we say, okay, remove 2 at the end, right? We don't need this, and we don't need this. Let me use red one. Then we start with the second one, right? We check it, doesn't work. So what do? It doesn't work for the second one. Then we check again, first one from here, doesn't work, doesn't work, doesn't work, and boom, it works. And then we remove all elements until we hit that position, which is basically this. But in this case, if we do one by one comparison before moving to the second one, right, before checking the entire thing, the problem is okay, let's see. Basically, all we need is bool function here, right? So bool equal, or maybe int, let's see, int, oh, which is matching size, right, of two strings. So we'll see S, R, and basically we can make them constant and just use reference for them because we don't care. I think so. So we will copy anything, whatever. And we don't need any indices, right? In this case. So let me see. Let me switch to the default scene. So let's also add this as namespace. Let's also specify this as namespace to give extra points for formatting. Let's even add the comment, call it helper. How much time we have? Ooh, we have like roughly 5 minutes. Chances are it's never going to work, but let's see. Return I. Right. Let's see, int I equals 0, j equals 0, or whatever. So, basically I is the width. So we need, I guess, just one. We don't need two. So we say initially that width is the entire as maybe length. So this is the best case scenario when it's a palindrome. So how do we compare it? Let's have for cycle. Int I equals 0, I less than s length, and I plus plus. So we say right, so we need to compare si equal to r length minus I to the last one, right? If something like this, so we keep checking until it's equal, right? No. We need two cycles here. We need also j here. And I think j will be from I, and it's also to j and j plus plus. So what do we do? And it's already quadratic as we see, because obviously it's quadratic, but maybe it will be slightly faster than substring. So what we check is basically this, right? So if it's equal, Then, oops, then we break and go to the second I, right? And start from the second element in the string. But for the second, it should be special one. I see. All right, so it's and then we can check the substring, I guess. It'd be faster. I don't think so. Yeah, I don't see the good algorithm how to do that. And we almost run out of time, so it's unlikely that we're gonna pass the test again, but at least we cracked the problem. Still interesting how we can crack this thing. Let's return to the whiteboard. All right, so let's see if something we're missing. So maybe adding some cue for the characters. And we refine one by one, and then keep sliding reverse until it's end, and then whatever characters are left, right? So imagine we have a queue like this. So we put this Y, B, S, blah, blah, blah. Or actually, maybe we can just use stack, right? So last in, first out. So then, let's say our ABCD case, so it will be D, C, B, A, right? So we start with A, and then we slide it against this DCBA string, right? And if we find for this one and for second one, let's imagine it was A, B, whatever, right? And then the third one aligns, then we left with one that we add to the initial string. Otherwise, we just basically don't care. Interesting. So but if it doesn't match, let's say the second doesn't match, what we do, we keep iterating, but now we put A back, right, to the stack. All right, let's try this. Looks like this can be the reasonable one. And then we return just string here. So we can just, do fun things with it. So let's see, stack char, let's call it S. Then we put to the stack, is it stack? So yeah. Right, stack by the way, isn't it? It's basically queue because we start from A and then just regular queue. We don't need stack. Sorry, let's switch to the default scene. Yeah, kind of a little bit on the time here, but basically we came up with ideas, so why not? Let's just code it. We may not count the points, but just to see if it works at all. Q, and call it Q. All right. So Q, I believe it's insert method. Insert. What we insert? We insert SI. That's it. Now we need to create a pointer int I equals 0. Then we create cycle while, where we say while I is less than s length or r length, doesn't really matter, there is the same length. And then length, we do something. Right. So what do we do here? We say if ri. So okay, Q will be most likely never empty, or it will be empty at the time when I is equal to s length. So we don't need this. Okay, so we say char C is equal to Q, I guess front, right? And then Q pop to remove it. So this is one from the top. So it starts with A, right? And then we say here, if a Ri equals to whatever, right, equals to C, then what do? We basically pop another element, right? And let's see if we can, and here we can create, again, string of, or maybe array, or maybe vector, and then push back, and then, right, so we add one. Whatever, let's see, temp. So if it's equal, then we say temp plus equal C, right? And char C is this, right? And then we do I++. If it's not equal, then else, then we should start all over, basically. And yeah, else we should do for so the problem with Q will add at the bottom. So let's use stack here. All right. Say S, and I believe it's push. So let's see. Oops. Stack CPP, gig for gigs, whatever. Yeah, it's push. Damn, you will never do this under 40 minutes. I mean, maybe you can, I don't know. But it doesn't look straightforward. Push S, and then I believe it's no longer front. It's called top, right? Top, yeah, exactly. But still pop. It's still pop. And it's S, and it's S. Else, we basically do, and then we don't need S, we basically need R now. Because initially, we take it from reverse. Oops, no, it's, oh, I called stack with S, which is this one, right? Yeah, let's call it Q then. Although it's not Q, it's stack, but we know that this is different, okay? So Q front, it's not front, it's top, and it's Q pop, and else, so if R is equal, I don't think we needed to do here. We needed to do here. We don't need to pop it every time unless it matches. If it doesn't match, we keep just incrementing until it matches, right? So if it matches, Ri is equal to C, and we know that this is reversal, right? When we do this for the reverse, it's so it pulls back A first, then B, then C, then D. So we pull first A. Let's say it matches. Then we pull B. Let's say it's not. Then we need to push B, then A back, right? And we need to push it in the reverse order, basically. So it's like, okay, so it's like temp equal C plus temp, something like this. Although it's not great. Should I create another queue? Or another stack, sorry. Another stack, let's call it queue reverse, which will be weird because it will be basically a queue window, right? Where we just, yeah, let's do this. It's better. So we just say queue window, push C, and it's also char, right? And then do this, right? Restart, go to the next character, increment I, and then compare next character to the next position. If not, if not, then yeah, I think it should be here. Sorry, we don't need string. It should be here. So if not, then push back whatever we have from that queue back to the original queue. Geez. It's a while. Queue window empty not it's like you're talking like Yoda while it's empty not try be not this guy. Okay, then what do? Then we do this. We basically say queue push queue window top queue window pop to remove all elements and we push them back to the original stack, right? Once we reach I, then our queue window, so if it's equal, right, whatever it is basically those letters that are equal, right? So let's say in this case, like in the DCBA, it will be only A. So what does it tell us? It doesn't tell us nothing. Oh, but we know the size, right? We know how much is too much. Yeah, so we know the size of the matching pattern. So basically, and we know two strings, so we can always do Q size, whatever was here, basically. So if this is matching, right, patterns, so what do we need is, yes, so it's the size of this matching pattern minus length. Yes, minus Q window what size exactly. So it's, in worst case, it's 1 when it's just the last one matches. In the best case, actually, if it's already palindrome, so what would it do? If it's a palindrome, so we push it to the queue, it's linear complexity, and we just basically top all of this, and basically, because they're all matching, we push them all the way to the. Technically, we don't need to even see here because we always can say, right? We always can say something, but whatever. It won't take too much space to have extra character, and we technically run out of time. So let's comment out this one. Solution, and just return let's call it get, how the problem called, palindrome, get palindrome, all magic happened in different function as usual. All right. And it doesn't work. Yeah. Looks weird though. What's the Q window size here? So if this is not matching then this, then we make it until it's empty. And then we increase. So in the worst case, the last element will match. We push it to the Q window, and that's it. All right. So it outputs what? It outputs this one. Interesting. I remember the same case we tried when we reversed basically and tried start not from the largest possible match, but from the smallest possible match. Is it the same case here? That's why it's not the shortest. But we start with the largest in the sense that initially Q window is empty, right? So we start from first, which is basically, so we add it from the reverse to the stack. Yeah, we want like the first one, I guess. And then we push back to the stack. So, interesting. Yeah, I'm not sure if I can just walk Q queue. Yeah, I don't think I can do this because it's a collection. It's likely it doesn't have any. Yeah, but way run out of time. So anyway, it won't count. But damn, sounds like the right approach to me. It's just something with yeah, like we push from the reverse. Should we push from the reverse? By the way, shouldn't we push from original string? Right? Push it first, and then it comes the last. So it's basically we will go reverse string, right? And then we can compare not with reverse, but with string here. So we don't need reverse actually in this case at all, I guess. But let's see. Shouldn't too much affect the complexity. Run the code to see what's going on in between. And I don't think it will print us anything. Yeah. Say stack to string cpp. Anything? Reverse string using stack. Gosh. Yep. So something is going on here. Whatever. Let's remove it. Let's just go with the example A, B, C, D here. Or maybe let's consider this example directly here. So after we push to the queue, right? So the queue here, queue is what? And this is stack. So first in, first out. So the first element here will be, so we push from the reverse, right? So it will be basically the entire string like this, C, E, C, A, A, right? Because we start with the reverse, we push this first, then second, blah, 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 blah. But because we push it the first, it will be the last. The last element we push here of the reverse string will be this one, right? Okay, so queue window is empty here, obviously, at the beginning. Sorry, queue is empty. So we start with char. At first it's C. So it suggests, oops, where it was, run code. Let me make sure what the result was. So if this is the string, right? A, C, C, A. So queue window was this size. Oh my gosh. It was the entire string. It's almost, so it matched only what? Basically these three elements or so. Let's see. So in this case, let's see. We compare. So it's not C, it's A, right? So basically it's this order here, right? And then we check R is what? Is A C E C A equals to C, which is this, right? So A equals to A, right? So what do? We push to the queue window A and move to next A. A is equal to A, right? We increment also I by 1, obviously. Okay, then we move to the next. C is not equal to A. No, it doesn't. So at that point, right, we move to here, equal to C. Ah, so we need to remove this only if this works. So this is the first thing that needs to be taken into account. What? Ah, yes, because we don't need, no. Let's keep it here. Yes, it's a bad thing because we modify it. So we don't need to remove it twice. That's why, because we will remove it here, right? Or maybe like this even. And then we say next one. We reassign it to the next one. Actually, that's why we don't need C, because we can just qtop here, right? It's basically this thing. That's what we need. Just need qtop. We don't need this thing here. It was for simplicity, but whatever. And then we don't need the reassignment here. And actually it's char C, oh my god, so it redefines it. So it was weird construction in the first place. So qtop. Qtop is just accessing the element, and then we remove it from the queue. When we move to the next one and push this one, once we don't need it, if it's not matching, then we push to the queue from the window until the queue window is empty. Nah, it's still bad. All right, so at least we know. So, okay. So we do what? A, it matches, C doesn't match, right? So at this point, two A's were added to the window. So we add A's back. So we restore the original one. I becomes what? It was. And I, do we need to increase I all of the time? Or only if it matches? Like, I wonder because technically if the first I doesn't match, right? We move I to this, once we repush the queue, we should decrement the I guess. And when it matches, we increment, right? So let's say it doesn't match, the queue is empty, so we increment by 1. But when we repush back, do we decrement I? And if so, by how much? Like I minus minus. So we recheck basically, right? The start with another one. Well, it's not the fastest way anyway, if we need to recheck it again. But yeah, I don't see any other way of doing this. Okay, so it was 2 and I was 3 at this point, right? We said, okay, I equal 2. actually, we don't need to do this because we know the size. So all we need to say is I equal to. So in this case, we now need to move to the first element again. So this is I minus equal what? Q window size. Is it this? Oh no. So the problem with that. Oh yes, and then we increment by 1. Exactly. Exactly. So let's say we went to 3, I equal 2 here, right? Then we say, yes, let's just move this one. Just say I minus minus. So we move, oops, we move to this third one here. C doesn't equal A, so we start repushing A back to the original stack. And at the same time, we decrement A. So I is 0, but we add 1 now. So I is no longer, so this one will be first element here. And then we redo this thing. Let's see. This I don't see there, yes, but there is no any speed up, I think. Will it pass? I don't think so. Nope. Still time limit exceeded. Okay, I give up. I don't know how to overcome this complaint. Still seems like yeah, even if we slide it not this way, right? So let me return back to the whiteboard. Even if we slide it this way, right? From the beginning. So we start with just 1, 2, 3, and then until we find the maximum, we still do quadratic complexity. There is no better way because every time we recheck elements. Let's see if we have something like the window here and here, right? So this is for reverse, this is for string. Then let's say we have some x, y, z, something z, y, x, right? So what we say, so this is not, so every time we shrink window by 1, we remove element from here, we remove element from here. But how do we compare it in a way that, yeah, because now x is against new element and y is against, yeah, I don't see the simple way. Okay, let's first of all go to the, so what we did in time is basically 119. This is what we did under 30 minutes. So we quickly came up with simple solution of quadratic complexity. We never reached to the, oops, no, this is 0. This is 0. Unfortunately, still 0. Yeah, bad. Feels like. Yeah, let's keep this. Maybe a little bit upset person now. So, okay, let's return back to the default scene and see what we've got for the answers. Okay, this guy come up as linear, but how? si plus r. Interesting. So there is still a way, pop back. There is still a way somehow to do this in linear time, but I just don't understand. So is it juggling with the strings? So we remove it from one, add it to the end or the beginning of another one, and something like that? Or no? Yes. Yeah, there is only one cycle. Interesting. And it does the thing. We start from the I equal 1 because definitely we don't care about the last element. Size equals to size. And then do something with it, otherwise we... The weird thing is we don't even check the elements with each other. We just check the size of it because we know that at some point, right, something should be equal to something, right? Yeah, I don't know. Okay. Oh, there is some special algorithm used for that. Add it at n such that it becomes blah, 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 blah. This is the palindrome, but the solution should be smaller. So we need to find the proper suffix in the reverse string that matches the proper suffix of input string and needs to be evaluated from the reverse string and insert remaining at the front. Proper suffix or proper prefix of the string is not equal to the string itself. Proper suffix or reverse string babar a b a a b a. Use of input string a b a b a b a. From above, it's clearly seen that the longest proper suffix that matches prefix are a b a. Yes, so the result is b plus a b a. In short, it goes in following steps. Generate reverse. We did it. S plus reverse. Oh, okay. Or I guess it's reverse plus S because we need to start from the beginning, right? Find the longest suffix of the appended string. And there's also prefix of the appended string. Suffix of the appended string. There is also prefix of the appended string. And then first the KMP lookup table needs to be generated. In order to generate the KMP lookup, the string shouldn't overlap, so step 2 becomes S plus ref S is used in order for the strings not to overlap. Without the string could mix each other and produce wrong results. For example, if it is A, then the ref string was A and the appended string is A. The longest would be of length 7, which is wrong, so the delimiter is added in between. So lookup. So what is the lookup here? Find the longest suffix that is also a prefix. Initially it's just length, array, length, right? Generate the KMP loop table that calculates the longest suffix that is also a prefix. 1. So there is a kind of hash, it's not a hash, but in table, which we say is what? I guess, corresponds to different length of the suffix, and int is the length of that suffix, right? So if isi and isj equal to each other, we say lookup plus plus I. All right, so we assign this plus plus I to j plus plus. So we move to the next one. Else, what do? If they do not match, then if I is equal to 0, then contents at I minus 1 will be I and should compare with contents of Sj. Interesting technique. Let's look up I minus 1, j plus plus, right? So it's something what I've tried to do with these stacks, but in this case it's not technically linear because you increment j plus plus here, but we don't decrement j plus plus. We don't do j minus minus. So yes, it's sort of linear. So in the worst case, we do twice of the length of this, sort of. So it's linear, yes. Interesting. So yeah, I didn't. Else, I greater than 0, then I look up I minus 1. Otherwise, look up j plus plus. Equals 0. And then generate the shortest palindrome. Reverse as substring rev as length minus lookup. That's basically what exactly we have returned, right? But this lookup, basically to find the size of the suffix, that took us square time. In this case, it can be done in linear time with this weird structure. Lookup. So for the lookup, every time we check it matching, right, we add 1. So at least one element matched j1. So then j2, we check the second element. If it doesn't match, that's the thing. So we don't really care, right? And do we? Interesting. This is why it's hard. It's not because it's a palindrome or whatever, or it's hard to find the longest prefix. This is because it's hard to squeeze it to the linear complexity without knowing some specific about the problem. I still don't understand how this works. To be frank, even knowing already, looking at the code and reading a few times through it, I guess at least until you go through the example, you will get the key here. So the key here would be that for lookup at step j, let's say suffix of length 1, all right, obviously if suffix of length 0, it's 0. If characters are in matching, there is a prefix that matching the suffix right. I see. I see. I see what was the. Ah, damn. So let's return back. So where we screwed up here today and why we didn't come up with something like this at the beginning. So remember this algorithm. So I said even if we move this way, there is no guarantee, right, uh, that we can do this in linear complexity because every time we need to recheck. No, we don't. So the thing is, we saw this is matching, right? It's obvious it will match. Then we move to the second one and check basically the second one matching. It's not. Then I said, okay, when we move, we need to recheck these three. No, we don't. All we need to check is check third one here, fourth one here, fifth one here, sixth one here. And the reason is it's linear, so you just basically check two strings in reverse, starting basically from this to this. All right, and for every step, you check how many uh, how many what? How many characters have matched, right? Uh, look up I minus one. Yes, exactly. All right. Yeah, so that was the trick. So you reverse strings, you put them sort of one on top of another, right? And then start checking this. Matches? Yes. Matches? Yes. Let's say matches. Yes. 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 So in this case, everything is matches. Interesting. D, C, B, A, B, C, D. So we start this. D is matching. C is matching, B is matching, A is matching. No, no, we need suffix and prefix. It's not like one by one. Obviously, then this CAA is not equal to this one. But the truth is, we don't really care. We can continue increasing. So that was the problem, right? So we said, okay, if it doesn't match, then we increase by one, and then we need to recheck the entire one. No, we don't. If this is matches, right? Like at this step, no, we always check one character. Interesting. Yeah, we check, okay, A, then C, not matches A, right? But then we do E not matches A, C not matches A. So we do not increment. Then we add A, it starts matching A, and then A is not matching A. But then we don't know if these are matching, right? So yeah, this table is still tricky, but I got the idea. So it's one pass through is sufficient. Then for every basically position here, we can track number of matched elements. And this will carry us, so the idea is to carry to the last element here, the largest number of, the largest suffix, basically. Ooh. Not easy. Everything. Entire life. So let's see. All right. So yeah, that's it. Just more things to learn. More practice is needed. Okay, thanks everyone. See you next time.